Hi friends, welcome back to my channel. In this video, we will learn how to describe or express a set. A set can be described or expressed usually in three ways. These ways to describe or represent a set are: number one is tabular form or representation. It is also called roster form. Number two is descriptive form. And number three is set builder form or notation. So first of all, we will study tabular form or roster form. As the name suggests, tabular means consisting of a table. We make a list of elements or tabulate the elements to represent a set. Roster also means list. So here is the definition. In this form, we list elements of a set within curly braces. These braces are curly braces, and elements are separated by using commas. In my previous video on basic concept of set theory, I had also talked on set notation or representation, and there I actually had told about tabular or roster representation of a set. And this representation is most commonly used when you study sets for the first time. This description can be used when we have elements of a set that are short or they are easy to interpret. Here are some examples to represent a set in tabular or roster form. The first one is n is equal to 1, 2, 3, 4, 5, 6 and so on. So this is set of natural numbers represented in tabular or roster form. The second one is w is equal to 0, 1, 2, 3, 4, 5, 6, 7 and so on. This is set of whole numbers represented in roster form. We have listed elements and the elements are separated by using commas. These are the commas to separate each element. The third one is z is equal to 0 plus minus 1 plus minus 2 plus minus 3. This is a set of integers represented in tabular form. The fourth one is a is equal to a, b, c, d, e and so on to v, w, x, y, z. This is set of English alphabets represented in roster form. And s is equal to a, e, I, o, u. This is set of vowels represented in roster form. M is equal to 0, 3, 5, 7, 8, 9, 10. This is set of some finite numbers represented in roster form. J is equal to lion, tiger, wolf, fox. This is set of 4 animals represented in roster form. E is equal to 0, 2, 4, 6, 8. Set of even numbers, first 5 even numbers 1, 2, 3, 4, 5 represented in tabular form. And here's the last example. O is equal to 1, 3, 5, 7, 9, 11 and so on. This is set of odd numbers. They are going up to infinity. It is an infinite set. The next representation is the descriptive form of a set. In this form, we describe elements of a set with the help of a statement. We can change this form into tabular form also. It is also called statement form or statement representation of a set. So here is the definition. To describe property of a set by using a statement, we use descriptive form. So here are some examples. N is equal to set of natural numbers, W is equal to set of whole numbers, P is equal to set of prime numbers, A is equal to set of English alphabets, and B is equal to set of animals. As you can see that we have written the statements to tell about the properties of the elements of the set. The last representation of a set is set builder form. The most important representation of a set to study is set builder form. This form is used when we want to tell the property of the elements of a set that satisfy their property. This is most widely used representation of a set at higher levels in mathematics. We can also change it to other forms, other representations I have explained to you right now. Set builder form is used when we have uncountable or too much elements that are difficult to write by using tabular method. So we use this representation. Overall, this is the most accurate way to represent a set as it gives correct information to the readers about elements of a set. A reader can easily understand elements of a set expressed in set builder notation. So here is the proper definition of the set builder form. A set can also be described by using a common property of its elements. This type of description is called set builder form. We can build a set if we have been given property of its elements. Before going to examples, we need to understand some symbols used in this description of a set. Why? Because this is actually a symbolic way to express properties of elements of a set. Here are some symbols used in set builder notation. The first one is vertical line segment, small line segment. This means such that. This colon also means such that. This symbol means and. This symbol means or. And this symbol means, I had also described this symbol, explained this symbol in my previous video. It means belongs to. And this capital Z means set of integer. And capital N means set of natural numbers. And this symbol means greater than or equal to. And this symbol means less than or equal to. This symbol means greater than. And this symbol means less than. This means there exists. Capital W means set of whole numbers. And Q means set of rational numbers. Now we look at some examples. E is equal to starting curly bracket. We used curly bracket in set builder notation also. These are used in either tabular form or set builder form. So X such that, this symbol means such that. X is a cube of whole numbers. What are whole numbers? Whole numbers start from 0, plus 1, plus 2, plus 3 and so on. So X is the cube of whole number. We can also write this in another way. E is equal to X such that X is equal to A cube. A is a whole number. So when we write it into a tabular form, this would mean E is equal to, the first whole number is 0, is 0, then when we write A is equal to 1, so X actually is the cube of A, so it would be 1. For 2 raised to the power 3 is 8, so 8. For 3 it would be 27. For 4 it would be 64 and so on, and the closing curly bracket. So the next example is X. This colon means such that. X is greater than 5. This symbol means and X belongs to. This symbol means belong to. It is a Greek letter which means belongs to. N, natural number. Natural numbers start from 1, 2, 3, 4, 5 and so on. 0 is not included in natural numbers. So we can write it into tabular form as X should be greater than 5. So greater than 5, what natural number is greater than 5? And that is 6. So 6, 7, 8, 9 and so on, and closing curly. And here is my last example. X such that X belongs to Q. Q mean rational number, and X should be greater than or equal to 0. What is rational number? A rational number is a number that can be written in the form of P over Q. P and Q are both integers, and Q should not be equal to 0. If it is equal to 0, then it would not be a number. It would be undefined. So here is the tabular form of this set builder form. We start with 0 because X should be greater than or equal to 0. 0, there should be no negative rational number. So 1, 1.2, 2, 2.2, 3, 4, 5, 5.1, 5.2 and so on. So this is the tabular form. Alright, thank you for watching my video. Please subscribe to my channel.